This video is about knowing the difference between average velocity and instantaneous velocity. But before jumping to our main topic, we must have knowledge of how the graph of distance differ from graph of displacement. A boy's destination is school who has started walking at 7 a.m. in the morning. Then he got tired after walking for 20 minutes, so he sat on bench for 5 minutes. He, while sitting, suddenly realized that he forgot his homework, so he rushes back to home to collect it. And then again move to his destination. Let us understand distance time graph for above case. From home to bench the graph is increasing. And for that 5 minutes on bench the graph become constant. And then while going to home in opposite direction for collecting homework, graph still increases. As distance which the boy is covering increasing. And then for same reason while moving towards school, graph again increases. This is the reason that why graph of distance versus time always increasing. Similarly, displacement time graph for same condition will be. From home to bench it increases, then on bench again becomes constant. But now while going back to home it decreases, unlike the case of distance time graph. Because in displacement we are interested in reaching our destination only. But while going back to home, boy is moving against its destination. Displacement is minimum distance between starting point and end point. And then finally from home graph again increases. Both speed and velocity, whether considered in average form or instantaneous forms, work on same concept except the fact that speed is distance upon time taken while velocity is displacement upon time taken. As we know that no process in the whole world can happen equally in equal time interval. Means sometimes process are fast and sometimes slow but cannot have same pace overall. Throwing a ball, flying of birds, driving a car. All such processes have therefore graph of curve form. In fact, our previous graph in case of boy was also not practically possible. No process can have straight line covering equal distance in equal time. We have used straight line here because we wanted to keep our starting simple and easy to understand. Now in order to understand the concept of average velocity, we are considering the graph of displacement versus time for the motion of a bee. Suppose the bee started from its hive to collect the nectar from a flower which is 60 meters away from his hive. After covering 50 meters, bee again started to move in opposite direction and at 30 meters it moves towards flower again. Also the bee covered distance 10 meters in first 15 minutes. But in next 15 minutes bee covered 20 meters. Means the motion of bee is not constant. But if the bee would have traveled with constant motion covering equal distance in equal time, which is practically not possible, then for that imaginary constant motion we introduce the term average velocity. Average velocity between any 2 points is total distance covered in between those points upon total time taken in covering that distance. Let A and B be 2 points on graph. Then distance between these 2 points will be 50 meters minus 10 meters. And time taken to cover distance between these 2 points will be 45 minutes minus 15 minutes. This will give us right angle triangle whose perpendicular is 50 minus 10 meters. That is 40 meters. And base is 45 minus 15 minutes, that is 30 minutes. Although the bee has taken curved path in between these 2 points, but we are interested in constant motion, so we taking into account the straight line between these points. In a so obtained triangle, on applying the definition of average velocity, which is distance covered by time taken, we get average velocity as 40 meters by 30 minutes, that is 40 by 3 meters per minute. Or approximately 1.33 meters per minute. Some students may relate it with perpendicular upon base equal to slope of hypotenuse. Yes, it is right. Average velocity is nothing but slope of line joining the 2 points. If this word slope is completely new to you, then go to our one of the videos on this topic. Now we will move towards our topic of instantaneous velocity. As we know that no motion in the world is completely constant. The graph of every motion is always of curve form. We have learned to find average velocity between any two random time points. Let A and B be such points on curves which passes through same displacement value, that is 2 km at two different times. One at 1 hour and other at 3 hour. Average velocity in between such points will obviously be 0. Because the difference in displacement value, that is 2 minus 2 km, is 0. Despite being time difference not equal to 0. But on the other hand, instantaneous velocity is the velocity at a particular instant. Instant is a time span less than even a second. It's as fast as blinking your eyes, and in fact more fast than that also. Let A be the point at which we want to find instantaneous velocity. Now in order to find velocity at this point, let us take another point at B on curve. Since we know from average velocity that in between these 2 points the average velocity will be the slope of hypotenuse of this triangle. Now we will move this point B closer and closer and more closer till we get the slope of line at A. But one may wonder that if we are decreasing distance and time continuously in this process, then we must have reached a value of 0 by 0 for instantaneous velocity at A. Yes, you are correct. Instantaneous velocity will ultimately give us 0 by 0 value, which is actually undefined value called as indeterminate form. But that doesn't mean that motion has no instantaneous velocity. This indeterminate form gets its correct value on differentiation. Now all these term indeterminate form, differentiation, along with limit continuity and integration are starting topics of calculus. We need to go through them once to get complete knowledge of instantaneous velocity. All these topics are difficult to put in one single video. So just go through these topics one by one. Thanks. For more maths related videos, do consider subscribing our channel, Math Shell.